So is it audible? Hello, 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 students.
Yes, sir, it's audible.
Okay.
Yeah,
Hello. My network signal is a bit problem.
Yes, sir.
My voice is not audible to you, na?
it's audible
Audible,
to
sir.
me and it's clear for me.
Clear.
Sir.
Can you see the presentation?
Sir,
Can you see the presentation?
no. Mm,
No. Mm.
No, sir.
Now, can you see it? Can you see it now?
Nothing.
Yes.
We can see.
Yes.
Yes,
Yes,
sir.
sir.
Okay. So in the last class yesterday, we discussed regarding what? We discussed regarding static friction, kinetic static friction, kinetic friction, rolling friction, fluid friction. Right? Yes or no? We discussed those topics, no?
Sir.
Yes, sir.
So what we will do today is we will discuss today. The next topic is what? Coulomb's laws of friction. Okay. So what does that law states? First of all. So first of all, the limiting frictional force is proportional to the normal reaction force. That means what? That means the limiting force. Suppose, suppose, suppose. Give me a minute, suppose this is a body. Okay. Now what we are having one normal reaction. Yesterday we discussed about it, no? Yes or no? And the another thing is what? We are having a limiting friction force. So here it will be the limiting friction force, and this one is the normal friction, and this one is the main F which is applied. Okay. So now these are the statements of Coulomb's. So what does Coulomb's law states? The first of all, limiting friction force is proportional to the normal reaction force. Then frictional force is independent of the area of the contact surface. Now look, if you have a box, suppose if you are trying to pull a very big box, huh? So if you are trying to pull a very big box, then that box will be occupying some surface area on the ground. Yes or no? Yes or no?
Yes, sir.
So now
Yes,
what
sir.
happens? Good. Now look. Now what happens? If that block is occupying some surface area on the floor, that area is not dependent on. That means friction force is not dependent on that area. Is it clear? Is it clear?
Yes, sir.
Okay. So this one is not dependent on the area, but it is dependent on how rough the surface is. Suppose I'll give you an example. If you try to walk over a tile, tiles, no, you know what is tiles? Yes or no? So if you try to walk over a tiles, what happens? It will your legs sometimes try to slip. Yes or no? Yes or no? But then if you try to walk over a concrete low road, which is rough, the surface is rough, suppose your your feet does not get slip. So this is what is dependent. That means that friction is mainly dependent upon the roughness of the area. Got it? It is not dependent upon the surface area. Is it clear? Is it
Sir.
clear?
sir.
हाँ उसके बाद number 3 में आओ. Number 3, what is number 3? Look, the coefficient of static friction is slightly greater than the coefficient of kinetic friction. That means what? Yesterday we discussed now there are two coefficients. One is for what? The one is for the static friction and the other is for what? Kinetic friction. So that means what? The coefficient of static friction will be greater than coefficient of kinetic friction. Okay. So this is an important graph that is, uh, now here this is what this F is the frictional force and this P is the what applied force. Got it? Now what happens? Up to static state, up to F limit, up to a limited point, it will be directly proportional. That means the applied force and friction, it both will increase. If applied force increases, then the frictional force will also increase. Got it? But then after certain period, after certain period, when the applied force is very high, yes, Temazat, any problem?
Uh, uh,
I'm not audible to you, Temazat.
uh,
Can you please write in
Hello.
the chat box? Please write in the chat box, Temazat. You're having some problem? Yeah. What about others? Dimodasi and all? Are you having some problem hearing my voice? Okay, reason for point 3. Okay. Now look, Temazat, you're asking this, na? So I'm giving you the answer. Look, what is static friction? So what Temazat asked me was the reason for this one. Why static friction is slightly greater than coefficient of kinetic friction. Now look, suppose your body is in rest. Huh? If your body is in rest and you try to move the body, but then the body is not moving. Then the friction that is applied on it, what is it called? Is it static or is it kinetic friction? Can anyone say me?
Static.
Yeah, very good. So it is static, right? But then what happens? You are applying some amount of force and the body is not moving, right? So the body is being stuck due to the application of certain amount of friction force. Okay, so that is static, right? Now in kinetic, if you suppose apply certain force to your body and the body starts to move, that means what? There is a kinetic friction, and that means what? You are applying certain amount of force on the body, and the body is trying to move. That means the frictional force that is being resisting your the movement of the body, that is not that much. Yes or no? Yes or no?
Yes,
Similar?
sir.
Huh? But then in the other case, in static case, what happens? When you apply the frictional, when you are trying to push the body, but then eventually it is not moving, then definitely the frictional force is higher now. So the coefficient of static friction is higher than coefficient of kinetic
Yes,
friction.
sir.
Clear now?
Yes,
Good, good, very good. So in the graph, if you see, this is a graph between your frictional force and what do you call it? This one, uh, applied force. So if you see up to a certain limit, certain extent, the frictional force is directly proportional to the applied force. But eventually, what happens when you try to apply more and more force, then this graph becomes constant. Okay, so remember this thing. Okay, are you
Yes,
getting
sir.
what I'm saying? You can take a screenshot of the graph if you want. I'm giving the notes in the ERP. It's a different thing. But if you want for your reference, you can take a screenshot. Now, is the previous topics clear? Are the previous topics clear?
Yes, sir.
Okay.
sir.
Huh? So now let us know relationship between angle of friction and angle of repose. Huh? So first of all, what is angle of repose? Angle of repose is defined as the minimum angle made by an inclined body made by an inclined plane with the horizontal such that an object placed in the inclined surface just begins to slide. Hmm. This means what? This means what? Can you can you get an example of it? Can you get an example of it? Can anyone say me a practical example of it where angle of repose is applied? Yeah, everyone, I'm asking. Please say.
Uh, for
Hmm.
different equal the
I'm not hearing
object
Temadar.
and
Temadar,
slide
I'm not hearing you.
and
You please.
end.
Temadar, I'm not hearing you. Please shift to a different location. I'm not able to hear you, Temadar. Can you please shift to a different location? Yeah, can anyone say? So you can continue. Okay, look. Hmm. Let me give you an example of it. Suppose what happens, you are trying to, you know, a log or plank of wood. Do you know what is a plank of wood? Any idea?
Yes, sir.
Hmm? Suppose you are taking in a plank of wood. Suppose you are putting a smaller log. Okay, you are taking, you are putting a smaller log. So what will happen after that? So if you try, first of all, that plank is suppose horizontal. Suppose that is horizontal. Now if it is horizontal, then what happens? Then the object will not slide, right? Yes or no? Then the object will not
Yes,
slide.
sir.
But then if you try to incline it little bit, huh? One after another. If you try to incline it one after another, then what will happen? Eventually, eventually that thing will try to slide down, no? Yes or no?
Yes,
Hmm.
sir.
Suppose you are trying to incline that plank. Hmm. So what will happen? Eventually that plank will try to slide down. Like like this one. Suppose. Here this is the plank. Hmm. So if this is the plank, suppose this is the plank. If this is the plank and this is the small log of wood, then what will happen? It is being inclined at an angle of theta, right? Yes or no? So the angle made by an inclined plane would be horizontal. That means what? This theta, the angle that is made with the horizontal, that means this one, after which, at which the small block will just start to move. Hmm. That means you are inclining the plane and eventually the small block will just start to move. So that angle is known as what? That angle is known as angle of repose. Are you getting now? Are you getting
Yes,
now?
sir.
So this is what is known as angle of repose. Okay? Is it clear now? So this diagram is very important. Huh? This diagram is very important so that you can show angle of repose. Is it okay? Is it okay, students?
sir.
Yes, sir. Yes, sir.
Now we'll go to the next. Hmm. Next is what? Angle of friction. Okay? Angle of friction. So what is angle of friction actually? Angle of friction is defined as the angle made between normal reaction and the resultant force of the normal reaction force. Now here, look at this diagram. Hmm. What you can interpret from this diagram? Can anyone say me? Can anyone say me what you can interpret from this diagram? I'll continue with it. Just I'm just trying to see how much you learn. Can anyone say me?
Resolution of force.
Hmm? No. From angular friction point of view. From angular friction point of view, what you understand from this? From angular friction point of view, what you understand? Can you say me? Look, I'll try to explain. I'll explain it. So if you see here, this is the R. That means what? This is the reaction. That means this R. Huh? Then there is one pull here. That means what? You are trying to pull the body from this side. And W is what? W is the weight. W means what? W equal to mg. You know, na? That means weight of the body. So if you are applying a pull from one side, then what will happen? On the other side, there will be what? This. This is what? What is this?
Frictional force.
Very good. So this is frictional force. So what we can do, we have written the R as like this. We can write, draw the frictional force in this manner. We can draw the frictional force in this manner. Yes or no? That means here, this and this are same. Yes or no? Huh? So what happens?
Yes, sir.
Ah. Hmm. So what happens after that? This frictional force and this R. There is R here and there is frictional force here. So they are making, they are getting a reaction, right? So the resultant, so these two, if you combine these two, then you are getting this resultant, this blue color. We discussed it now. If you add these two forces from triangular law, then this will be the resultant. Now this resultant makes an angle of what? Theta with the horizontal, right? So this is the angle of friction. So hence angle of friction is defined as the angle that is made between the normal reaction, that means this one, and the resultant force. Resultant force is what? This one. Oh, sorry. This one. This one is the resultant. So this resultant and the normal reaction, the angle that it makes, this is known as the angle of friction. Now, how to find out angle of friction? Hmm. So angle of friction, you can write it as tan theta. Tan theta equal to F by R. Yes or no? Perpendicular
Yes, sir.
by base. So F equal to, F equal to, remember one thing, F is equal to always mu into R. Where mu is what? Mu is called the coefficient of friction. Okay? And R is the what? Normal reaction. So the frictional force F is equal to what? Mu into R. Are you getting? Is it clear?
Yeah.
Hmm.
Yes,
Now,
sir.
hmm. So now, what happens? Let R be the normal reaction and F be the frictional force. So that is R is here, the normal reaction, and the F is the frictional force. Therefore, F is equal to what? Mg sin theta, and R is equal to what? Mg cos theta. Can you tell me why it is Mg sin theta and Mg cos theta? Can you tell me? No? So look,
because in mg sin theta, because angle is
theta, and the
uh,
mg is the what?
left side.
Resultant. So mg is the resultant. Now if you take this one theta here, that means sin theta component is what? This one. So if this is theta, f plus r equal to mg, then the sin theta component will be what? F, and r will be what? The cos theta component, right? So if you divide now this one and then this one, mg sin theta by mg cos theta, then you will be getting what? Then you will be getting this. Then you will be getting this equation. So f by r equal to mg sin theta by mg cos theta. But we all know from the previous one that tan theta is equal to what? From here, from this relationship, we all know that tan theta equal to mu. Yes or no? So we can write like this, now. Tan theta is equal to mu, or tan theta equal to what? Tan alpha. That means what? Alpha is equal to mu, where alpha is the what? Angle of friction, and theta is equal to A. Therefore, angle of repose is equal to angle of friction. That's it. Okay. So in this way, you have to know angle of repose. Yeah, Mito, you have raised your hand. Any problem? You
Sir,
Sir,
got
I did not understand, sir, mg sin theta and mg cos theta.
MG sin theta, MG cos theta. You didn't understand. Look at this diagram.
Sir.
Hmm. Look at this diagram. In this diagram, what is there? This is theta, na? Yes or no, mu?
Yes, sir.
Now, if this is theta and f plus r equal to what? I told you, na? F plus r equal to mg. Yes or no? F
Yes,
plus
sir.
r equal to mg. Huh? F plus r is equal to mg. Then what happens? If this is theta, then the cos theta component will be here, na? Mg cos theta. This side will be mg cos theta, right?
Yes, sir.
Not understood or understood? Mu?
Yes, sir. Understood, sir.
So mg cos theta will be this side, right? So that means what? This one is already हम लोग को पता है कि ये क्या है? ये r है कि नहीं? Yes or no? We already know that this is r,
Yes,
right?
sir.
But then we can write like this, na? R equal to mg cos theta. Can you write or not?
Yes, sir.
Similarly, if you put this here, this will be in this direction, then it will be what? It will be mg sin theta, right?
Hmm.
So if
Yes,
this
sir.
is sin theta, then this one is what? F. Yes or no? So that is why we are writing
Yes,
F
sir.
equal to mg sin theta and mg cos theta. Okay?
Yes, sir.
Okay?
uh,
Yeah,
so
Tenadar.
sir, according to diagram, that means when area is increased, the object is bigger, then the angle will be larger.
No, it is not dependent upon the object and the angle. Not dependent upon the area and this one. This is just dependent upon the resultant. What angle the resultant is making. That means what? How much amount of F and how much amount of R is there. Got it? It is not
Okay,
dependent
okay.
upon the area. It is dependent. Suppose look, this is F plus R, na? Again, so this F plus R is making an angle theta. This angle is dependent upon this one, these two values. Okay? Okay? Hello? Hello.
Yes, sir.
Sir.
Yeah.
How A plus R equal to mg?
Remote asi asked na. Yeah, I got the question. Look. I'm telling you. F plus R means what? This is the total reaction force that is being applied, na? Yes or no? Yes or no? This total reaction force, this will means what? We know F equal to, we all know this, na? F equal to ma. Yes or no? Now here,
Sir.
yes, yes or no?
Yes, sir.
Yes, sir.
Sir.
Now look. Now Kabom and who asked? Kabom and someone asked me the question. Okay, it's good. So yeah, remove. So what happens? Look, pay attention. F equal to ma. Yes or no? So if F equal to ma, that means this is acceleration. Now here, this object is what? Undergoing or experiencing a force W. W means what? W means what?
mg.
mg.
Yeah,
Yes.
W means mg. Now because of this mg only, these two are relevant, na? This reaction and this friction. These two are relevant only because of this mg, na? अगर mg नहीं होता, if you are not acting upon the gravity, then this one and this one won't exist. Yes or no? है कि नहीं? That means what?
Yes.
These two things will be, that is why F equal to mg. Okay, got it now? Got it?
Sir,
Bolo.
sir, does it mean that the weight of an object is equals to the sir, frictional force?
No, no, not frictional force. This one is F and this one is frictional
Friction
force.
force.
Look, friction force we are giving a dash here, ना? समझ रहे हैं?
Yes, sir.
फ्रिक्शनल फोर्स अलग है. ये फोर्स नॉर्मल रिएक्शन फोर्स है, जो बॉडी का फोर्स है. तुम्हारा सपोज तुम कहीं पे खड़ा हो, यू आर स्टैंडिंग समवेयर, देन व्हाट, यू आर एक्सपीरियंसिंग सम फोर्स ड्यू टू ग्रेविटी, ना? देयर इज अ डिफरेंस बिटवीन वेट एंड मास. यस और नो?
Yes,
Mass means
sir.
what? The amount of thing that matter that is present in the body. But weight is what? It is because of the acceleration of the gravity, right? So there is what? Gravity is acting now here. Yes or no?
Yes, sir.
So that is why we are getting it mg. Okay? क्लियर है कि नहीं? थोड़ा सोच के देखो, जस्ट थिंक ओवर इट. थोड़ा इमेजिन करके देखो, कोई बात नहीं है. यू कैन आस्क मी एनी टाइम यू वांट. अभी समझ में आ रहा है कि नहीं? थोड़ा
जी सर.
समझ में आ रहा है? तो बेसिकली
थोड़ा तो आ रहा है
जी
सर, बट
बोलो. बट क्या? बोलो.
सर
हम्म
उसमें क्या स्टैटिक्स एंड स्टैटिक और काइनेटिक तो क्या
बोलो.
उसमें
लुक
डिफरेंस
दोस
होगा क्या
थिंग्स, लुक दोस
फ्रिक्शन
थिंग्स.
में?
Do not think of so much complex. Just think that a frictional force is acting here. Okay, a frictional force is acting here, right? And this reaction, normal reaction, that means what? The body is giving a reaction. Now look. Now what happens? This, you know, now the force is always conserved. That means there is no loss of force. है कि नहीं? है कि नहीं? That means
यस सर.
ये बॉडी जो रिएक्शन देगा, नॉर्मल रिएक्शन, दिस बॉडी विल गिव सम रिएक्शंस, ना? The reaction that this body will give and the frictional force that is being arise, these two force, if you combine these two force, this should be equal to this one for the body to be in balance. Yes or no? Yes or no?
Yes, sir.
Yes.
So these two, suppose look, this is one force, this is one force, this is the friction and this is the reaction, right? Now if these two, you have to combine these two, then only you will get this, ना? And W तो पता है हम लोग को mg है. mg क्यों है? This is W. W is what? This object will have some. This object will have what? Some amount of mass. Again, and G is always acting downwards. The acceleration due to gravity.
Yes.
So that means what? The total comes out to be mg. So you have to apply this amount of force to make the body move, na? So that means mg is the reaction.
Yes, sir.
समझा?
Okay.
अभी समझा
Okay,
सब लोग?
okay, sir.
What about others? Same other is understood. What about others? Mu and all? Did you guys understand?
Yes, sir.
Yes?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Just try to imagine the thing. This is very beautiful. Try to imagine it. You'll understand it. Not that difficult. Okay, so this is how we'll be finding out the reaction. Okay. Now I'm telling you again. Look, up to this part, do you understand how did this came? F equal to mg sin theta and mg cos theta. Number one and number two, you understand? Yes
Yes,
or no?
sir.
After that, what happens? Look, now we will find out the ratio of F by R here. So we'll be finding out the ratio of F by R. This one. So this F by R ratio is given by mg sin theta by mg cos theta. That means what? We'll be getting tan theta. Yes or no? From this mg get cancelled like this. तो sin थीटा बाय cos थीटा कितना होता है? tan थीटा होता है. कि नहीं? Yes or no?
Yes, sir.
Then after that what happens? Look, this tan theta, we already proved that tan theta equal to mu. Yes or no? So we wrote here tan theta is equal to mu, where mu is the coefficient of friction. Okay. Now after that, let us think mu is equal to tan alpha. This one. Let us assume mu equal to tan alpha. Then what happens? You can write tan theta equal to tan alpha. You can write or not? You can write or not?
Yes,
Sir.
sir.
So then let us think that alpha is the angle of friction. Then that means what? Tan theta equal to tan alpha. Then theta equal to alpha. As simple as that. Okay. So therefore we can prove that angle of repose is equal to angle of friction. Is it clear? Students, is it clear?
Yes, sir.
Yes,
Okay.
for me, sir.
Okay. And what about others? Is it clear? Everyone should respond now. Is it clear?
Yes, sir.
Okay, good. Very good. Very good.
Yeah.
Okay. So now, yeah, Crow, you have any doubt? Crow, you have any doubt?
No,
Speak.
sir.
No. It's okay.
No, sir. Yeah.
Okay.
Yeah.
So, you can do this in this manner. So, is other topics clear? Angle of friction and angle of repose. Other topics
Yes,
clear?
sir.
The angle of friction and angle of
Yes.
repose. So, how to prove angle of friction is
Yes,
equal
sir.
to angle of repose? So this proof is very good, very much interesting and important. So study it properly. Okay, this angle of friction and angle of repose. Okay, so this thing is very much important. Okay, any doubt you can ask me. If you have any doubt, you can ask me.
No doubt, sir.
Mhm. Okay. Okay. You can do one thing. Just give your attendance. Okay. Answer. Sorry. The resultant force's direction. Yeah. Answer is answer goes downwards. No, the resultant will be towards the both the forces. No. If you see in the PDF, the resultant will be in this direction. If you see the PDF here, resultant will be in this direction. No. Ansari. Okay. Is it clear, Ansari?